Good morning, students. Welcome back to our software engineering class. We are discussing about software architecture. In the last class, we have defined what is that software architecture is, where it is placed, how important it is, and how it is going to affect the subsequent activities of the software development. Those things we have discussed in the last class. And in this class, we are going to discuss about various views of the software architecture. And before that, what is the importance of architecture description document? For the requirement specification, we have a SRS document like that. For the software architecture also, we have architecture description document, and that gives us a communication between the various stakeholders of the development. Okay, so let us resume with the importance of and usages of the software architecture description and various views of the software architecture. Okay. Well, one of the usage of this software architecture description document is understanding and communication. Okay. See, an architecture description is primarily to communicate the architecture to its various stakeholders. Yes, okay. So, various stakeholders here include users of the system, clients who are commissioning the systems, and developers. So, these are all the stakeholders. They have to communicate themselves for effective development. So, this software architecture is used for communication. Okay, then uh, the next usage is reusing it. Okay, see, an architecture description can help the software for reusing it. Okay, uh, the reusing is one of the main technique by which productivity can be improved. Okay, it reduces the cost of the software development and delivery time. Everything can be reduced by reusing the existing description of the software architecture. Okay, if it is possible. Okay. The third one is construction and evaluation. That is another usage. Uh, this architecture partition the system into parts. Okay. Various parts. Some architecture provided partitioning very naturally. Okay. And that can be used for constructing the system, that partition. Okay. By partitioning means we are breaking the system into various parts such that each part can be developed separately by different teams. Okay, and they can work on these separate parts. So by that way, each team can dedicate himself to the particular aspect. Okay, then the last advantage of this description document is analysis. See, some important properties like behavior of the system can be determined even before the actual system is developed. When we go through the architecture description, okay, how the system is going to behave, everything can be predicted from the architecture description document itself. So This will allow the designers to consider alternatives and select one that will be best. Okay, if they find some difficulties, if they find some drawbacks in the description, that can be rectified here. Okay, then these are the advantages of architecture description document. Okay, now we come for the architectural views. Okay, see, when you try to develop a software, there are different forms of architectural views. There is no specific single unique architecture of a system. Okay, see, you take the construction of a house. Okay, see the construction of that house, the plan of that house can be viewed in various views. Okay. Mm, For example, a civil engineer constructing that house will look at the blueprint of that house. He bothers mainly about the blueprint of that house. Okay. Then a plumber looks at the building from the water connection levels, various pipes, where it is going, and like that. Okay. An electrician will look at the house from the electrical point of view. What are the various electrical wires, wiring, where is the meter box, and how the connection will be given from one room to another room, whether it is going to be a single phase connection or three phase electrical connection like this. So he will look at that building from the electrical connection point of view. So various people will look at the house at different angles, different views, but all of them are not completely independent of each other. They are all related. They are all related. So construction of a building can be viewed at different angles, different views. Like that, in the system, in the construction of a development of a software system, the architecture can be viewed at different way, different, no specific architecture of a system. There are different views. So how many, whatever be the number of views available, they all come under three categories, namely a module view, component and connector view, and allocation view. They come under three categories: module view, component and connector view, and allocation view. See, all these views cannot be said they are completely independent. They are in a way related with each other. Okay. So in this architecture views, we will mainly concentrate on this component and connector view. Okay, though the other views are also there, we will emphasize more on this component and connector view. So what do we do in the module view? What do you see about the architecture and the module view? In the module view, the system is viewed as a collection of code units, and each implementing some part of the system functionality. Okay, for example, polynomial addition is a problem means, then uh, the reading a polynomial is one module, adding to a polynomials is another module, and displaying the polynomial is another module. Like this, the problem is different, is divided into various code units, like reading a polynomial, writing a polynomial, adding a polynomial, like that. So in the module view, the system is viewed as a collection of code units. Okay, and each implementing some part of the system functionality. That is, the main elements in the view are modules. Okay, These views are code based and do not explicitly represent any runtime structure of the system. Okay. Some examples of the modules are packages, class, procedures, methods, and functions, collection of classes. Like this, these are all some of the examples of modules. They are not completely independent; they are related. Okay, the relationship between them are code based, and they are all okay. Coming to component and connector view, component and connector view. In the component and connector view, the system is viewed as a collection of runtime entities like components. Okay. In the module view, we saw the system as a collection of code units, namely module. But here we see them as a collection of runtime entities called components. So this component is a unit which has an identity in the execution system. Some examples are objects, collection of objects, processes, or some of the components. Okay. So during execution, the components need to interact with others to support the system services. Okay. So these the components, they support the system services. Then what is this connectors? These connectors provide some interaction between the components. Okay. Examples of components are pipes, sockets. These are all some of the examples of connectors. Okay. Uh, if components use some middleware to communicate and coordinate, then the middleware is a connector. Okay, so they perform some interface between various components. Okay. Next comes this allocation view. An allocation view focuses on how the different software units are allocated to resources like hardware, file systems, and people. How the resources are allocated. Okay. An allocation view specifies the relationship between the software elements and the elements of the environment in which the software system is executed. Okay. This allocation view expose the structural properties of the system, like the processes run on which processor, uh, how the system files are organized in a file system like this. These things are explained in the allocation view. Okay. So as I told you already, these views are not completely independent. They have some relationship between them. Okay. Sometimes the relationship might be very simple and sometimes the relationship might be very, very complex. As I told you already, we are going to bother much about the component and the connector view only, and we will discuss more about this component and the connector view. Okay. Now, component and the connector view. Two main elements of the component and the connector views are components and component components and connectors. So what are these components? The components are usually computational elements or data stores uh, that play some role during the system execution. Okay. Then the connectors define the means of interaction between the components. Okay, how they interact with how two components are interacting with each other is defined by the connectors. Okay, so As a whole, a component and connector view of the system define the components and which component is connected to which through what connector. Like this is explained in the expressed in the component and connector view. And also a component and connector view describe the runtime structure of the system. So which component is existing when the system is executed, uh, and how they interact during the execution, and all these things are defined in the component and the connector view. Okay. So what is we have a, detailed discussion about these components. See, these are all some of the example components: client, server, databases, applications. So these are all some figurative examples of components. Okay, components. Components are usually, as I told you, they are all units of computation or data stores in the system, like server, database, applications, clients, and these are all some of the examples of components. Okay, so every component has a name, um, and the name should reflect the function of that component. Okay, and the name also gives a unique identity to the component. Okay, each component should have a unique name. That is the idea. Okay, the every component has a particular type, data type. So the data type is nothing but the component type. So a component is of a component type. Here the type represents a generic component defining the general computation, and the interface as a component of that type must have. Okay, so the data type of that component is a quite generic one. And how they interact with each other through the interfaces. Those interfaces are connectors. Okay, so components use interfaces to communicate with other components. Okay, sometimes we call them as connectors or ports. Okay, so this is an example. Okay, coming to connectors. Different components of a system are likely to interact with each other when the system is in operation. Okay, then only they can provide the required services out of that system. Okay, so they have to communicate with each other. Okay, so these connectors behave as an interface between various components. Okay, this is an example of various connectors: a bus type connector, database access connector, request and reply connector, pipe, RPC. See, note that the connectors are binary, so they connect two components. Two components are connected. Two components, okay, but it is not necessary that connectors connect two components. It can, that is, they need not be binary. They can be they can connect many components, not only restricting to two. Okay, NV communication. NV communication between various components it can perform. Like a component has a name, a connector also has a name, and that name should describe the function it performs, and it should describe the nature of the interaction the connector supports. Okay, and just like a component had a type, the connectors are also has a type, and this is also a generic description of the interaction. Okay, so that is connectors. Okay. Okay. So in this class, we saw some of the basic things about components and connectors. Okay. Next, our discussion is about architecture styles for component and connector view. Architecture styles for component and connector view. See, there are different styles are available for component and connector view, namely pipe and filter, shared data style, um, client server style. Like this, there are different architecture styles are there. See, pipe and filter. Shared data style and client server style. Client server style. Okay. What is this pipe and filter style? See, this pipe and filter style is well suited for systems that primarily do data transformation. Okay. Uh, what do they transform? They perform data transformation of some input data received, and the goal is to produce some output data by suitably transforming the input data. So simply saying, this pipe and filter style of component and connector view is suited for systems that primarily do data transformation of some input data received. And what is the goal? The goal of the system is to produce some output data by suitably transforming the input data. That is the thing. Okay. This style has only one component type called filter. Okay. Uh, then if it has component means, then it should have connectors also. The connector type is pipe. So the component here is filter and the connector is pipe. And the pipe connector is a unidirectional channel here. Okay. So that is about pipe and filter. Then coming to this shared data style, here there are two types of components. In the pipe and filter, we had only one component, but here we are having two types of components, namely data repositories and data accesses. Okay, data repositories and data accesses. Components of data repository type are where the system stores shared data. Those could be file systems or databases. Okay. Whereas the components of data accessor type accesses data from the repositories, perform computation on the data obtained like this. Okay. Then this style, when components are there, they should have connectors are also there. Then coming to client and server style, the client and server style of this component connector view, there are two components types, namely user, namely clients and servers. Two components. The components are client and servers. Okay. There is one connector called request and reply type. Okay. This connector connects the client to a server. Client to a server. Okay. A constraint of this style is that a client can only communicate with the server and cannot communicate with the other clients. Okay, that is the drawback of this component on the connector view. Okay, so the communication between the client component and the server component is initiated by the client, and when the client sends a request for some service then the server supports. Okay, so that is this client and the server style. So we have discussed some of the main topics about um, architecture description, software architecture. Okay, then how to document the software architecture design. Okay, that is the next idea. That is documenting the architecture design. Documenting the architecture design. So these things we will see in the next class. Okay, how to design, how to document the architecture design, and those things we will see in the next class. Okay.